Hey Pre-Calc, we are continuing on with 7.5. We're going to be graphing with all of our transformations we've learned from a long time ago. So just real quick, we make sure that we are familiar with our parent function. Now if you notice, our base in this problem is 2. And so without doing anything, you should know that if a base is bigger than 1, which it is, then we have a growth function. So in case you have forgotten, which I don't think you would have, you can plug in these values for x, and 2 to the 0 power would be 1. So we're talking about this graph is going through at 0, 1. If I plug 1 into the power, well, 2 to the first power is 2. So we have the next ordered pair at 1, 2. I don't know if I need to write out the ordered pair here, or if I even need to really write out that you understand what I'm doing. I think that you guys could all do this without my help. So when x is 2, plugging in 2 into the exponent, we get 4. So 2, 4. And please remember that when you plug in a negative exponent, that makes it a fraction. If you need to, think of it as 2 to the first. So the ordered pair at x equals -1, we get 1/2. And then at x equals -2, just remember that 2 to the -2nd power would be 1 over 2 squared, or 1/4. And just a reminder that even though we have negative x values, does not mean we get negative answers. We just get fractions with negative exponents. If we plugged in 3, it would go all the way up to 8. And all of the things that we've learned before this are still true. Where we have a horizontal asymptote at y equals 0. And right now, all I'm trying to get you to recognize is that we have a parent function. And so let me quickly go through the exponential decay here. This is decay because our base is 1/2. And that base is smaller than 1. And it says decay right here. But remember, if we plug in to the 0 power, even though 1/2 is smaller than 1, to the 0 power still gives me a positive 1. And so it has to be going down and to the right, and we can confirm that it's going down and to the right. That was a terrible point, because if I had 1/2 to the first power, I get 1/2. So that's my ordered pair 1, 1/2. And then 1/2 squared, in case you've forgotten over the years, you just square each piece. Well, 1 squared is still 1, and 2 squared is 4. That's why I was saying this was a terrible place to put it. It should be a little bit lower. But my horizontal asymptote is still at y equals 0. I still do not get negative answers. And just a reminder is if you have a negative exponent, maybe I'll show it this way, because I've seen a lot of teachers show it in different ways. If you have a negative exponent, then you have to move it to the denominator, or if it's in the denominator, move it to the numerator. So when x is -1 in this problem, we do get positive 2. And same thing with this one. I'll just kind of jump ahead because we have more important things to do, is you'll go up to 4. If we had x is -3, it would go all the way up to 8. Okay? And you can double check this is correct with a graphing calculator. Okay? But I anticipate you guys fully understanding that. So as we look at our shifting and reflecting rules, I want to make sure I'm not forgetting anything, so I'm going to pull up the answer key. Just a reminder that if we have the negative a value, it's going to be an x-axis reflection, and it might help you to remind yourself that if we have an x-axis reflection, the y-coordinates change signs. And if we only change the x value to be negative, then it's a y-axis reflection. As a reminder, if we add or subtract on the outside, so like that c value is on the outside, that's shifting up or down. Sometimes we actually put that plus or minus in front of f of x, but that's increasing all the y-coordinates, or decreasing if it's negative, and then the plus or minus shifts left or right. And remember, it's backwards. And I'm going to try my best to remind you of some of the rules as we do this, and the whole purpose is to help you graph faster. Okay? When in doubt, you can always make a table of values and come up with your answers. So go ahead and hit pause on your video if you need to remind yourself on how to do any of these. So as we look at this problem, the first thing that they want you to do is just label your transformations. So the order does matter. So what we want to do is identify the reflections first. So if you notice, we have a reflection in front. It's a negative a value. So that is reflecting over the x-axis. And we've been practicing this. And then the next one, it doesn't matter if you shift which one you do next. So 2 and 3 can switch orders. So I'll just put like a little box here that you can switch these two around. This order doesn't matter, but I do like to see the reflection first, is the 2 shifts. Now remember, if we're inside, we're adding to the x, it's backwards. So it is left 3 units. And then this plus 2, as we've talked about before, that's your horizontal asymptote, is shifting up 2 units. Now, what you may remember from a long time ago is we made a rule where we wrote x, y, and then we put arrows on how everything changes. So when we talk about these reflections, it might help you to create that table of values to come up with the answer. So remember, flipping over the x-axis negates the y value, and then shifting up 2 units will add 2 to those values. And then because it's x plus 3, that's shifting left 3, the x-coordinates need to be the opposite, x minus 3. And hopefully you remember doing this from a lot earlier in the semester. So the reason why we would write all that out is so, if we made our chart of x, and you don't need all of the points. I know the directions had, and I'm just going to do the positive ones because I don't want to do all of the points. Is when we plugged 0 in for the graph of f of x, 2 to the 0 power was 1, 2 to the first power was 2, and 2 squared was 4. Well, if we follow these ordered pairs and we follow these rules, maybe I'll highlight for a second. So the ordered pair was 0, 1. Well, if I'm going to shift left 3 units, I'm going to take the x-coordinate of 0 and subtract 3 from it to make it negative 3. And then the y-coordinate, well, I have to negate it first and then add 2. So it's negative 1 plus 2 would give me a y value of 1. So I can do that with all of these. So take the x-coordinate, 1 minus 3, and you get negative 2. Look at the y-coordinate and negate it, so negative 2 plus 2 would give me 0. I hope you see where I got that 2 from. So then the next ordered pair, 2, 4, I have to do 2 minus 3, the x-coordinate minus 3, is negative 1. And then the negation of the y-coordinate, so negate 4, plus 2 will give me negative 2. So I think this is helpful, that we can now graph this at negative 3, 1, negative 2, 0. And notice I don't expect a lot of points because I think that you could graph this, I'm doing this last one by the way, with just 3 points, because I think it's pretty clear from here where your asymptote would be located based off of those 3 points. Now, if you're confused, why is your asymptote going to be at y equals 2? We could easily, go up and find how it was shifted up 2 units. up 2 units. So instead of the horizontal asymptote being at y equals 0, the horizontal asymptote will be at y equals 2. So horizontal asymptote at y equals 2. Why? It was shifted up 2 units. So a normal horizontal asymptote at y equals 0, well, if that needs to be shifted up 2 units, well, up 2 from 0 is 2. And this is more of a step-by-step methodical way of getting to this correct answer. And we can confirm that this is correct based off of some of the other things we've learned. Like we have a base that's larger than 1 with 1 reflection, so it should be exponential decay, which is exactly what we have going on. And just real quick, we also asked for the domain and range. I just realized that they asked for that here. The domain is all reals. Every exponential function will have all reals there. Now the range is based off of the fact that we're below the horizontal asymptote, so it goes from negative infinity until you get to that horizontal asymptote, not including the horizontal asymptote. All right. I think I have enough time to do one more, but I'll have to finish this in a second video. Because as a reminder, and because it's been a while since we've done this, when we have a negative here, it puts a wrench in our transformations. But you may remember that what we did a long time ago is we set the equation equal to 0. The argument, that's what we called it, the argument equal to 0. And we solve for x to see that, okay, well, if I add x over, it's negative 3. X equals negative 3. So this is really shifted left. Three units. The other thing to mention, so this is actually the second transformation I'm going to name, because the first one I should have named is that we have a y-axis reflection, because x is negative. And then this minus 2 is telling me that we need to shift down 2 units. Now, what's the other thing that we learned a long time ago? Is we learned about that x comma y becoming something new. And if you remember from that long time ago, is when this was negative, we left it all the same. So it was negative x minus 3, which is confirmed by the y-axis reflection being a negative x, and left 3 is minus 3. And then if we shift something down, we're changing the y units by subtracting 2 there. So if we did the same ordered pairs as I mentioned, maybe I'll do it this way. I'll just write f of x to, was this called h of x? There we go. And again, I'm only going to pick the 3 easy points, like 0, 1, 1, 2, and 2, 4. Those are the ordered pairs for f of x equals 2 to the x. Well, if I follow these rules, I negate the x-coordinate minus 3. I get negative 3 there. And I take the y-coordinate, which is 1 here, minus 2, would be negative 1. So now negate the x-coordinate. So negative 1 minus 3 is negative 4. And then 2 minus 2 would give me 0. Again, plugging 2 in for y. Plug in 2 in for x. Negative 2 minus 3 is negative 5. Plug in 4 for y. Minus 2 is 2. So if I graph these, negative 4 is 0. Negative 5. Whoops, I definitely messed up there. So what happens when you rush negative 3, negative 1. Negative 4 is 0. Negative 5, 2. And as you connect these dots, it's pretty clear that your horizontal asymptote, at least I think it's clear, is y equals negative 2, which should make sense because we're shifted down 2 units. So we have a horizontal asymptote at y equals negative 2. We have decay because we had a base that's larger than 1 with 1 reflection. So that makes perfect sense. And I'll have to see you in the second video for the rest of the notes.